line
Okay.
like representation.
Mm-hmm.
And in multiple regression, it comes as a curve. So many times you have to uh, do the regression analysis, and then it gives like it. That is what my understanding is.
Yeah, yeah. So it will be not exactly a straight curve if you just take multiple aspects, because now I have just
Maybe
rounded
like
off.
hyperbola or parabola type something.
Yeah, because of influence of multiple variables. So because of that, it usually comes like that. But when we try to fit it as a line, it also resembles a straight line. But the concept is like, if the dependent variable is one and independent variable is also one, probably then it is called as a linear regression. And if any particular dependent variable is influenced by multiple variables or many variables, then we call it as multiple regression. Okay.
Mm.
So in the last class, we have just seen that if pass percentage is very good, so that means the teaching might be good, students are very, very studious, and the question paper might be easy, evaluation might be, there might be multiple reasons for getting the higher grades for all the students. So that is example for multiple regression. And coming to the linear regression, if at all any particular variable is dependent on one variable, like if you just feel that smoking causes cancer, assume that smoking causes cancer, and if you try to find out what is the cancer levels for 10 smokers or 20 smokers, so in that case, we try to fit a trend line or a regression line that how much is effect of the smoking on cancer cells, like that. So there we try to consider only one sort of variable or one variable. So that is linear regression, multiple regression. In if you see in this case, like the first problem which we have seen, I have taken only 5 samples. So sample number 1, 2, 3, 4, 5. And here we just wanted to find, is there any impact of height of mother on height of son? Okay, so is there any impact of height of mother on height of son? So here we are trying to find out the regression equation with only one variable. Okay, here we are assuming that son's height, the height of son is how far it is dependent on the mother's height. Okay, we try to fit a trend or a regression line, and we check how much variation or how much percentage of son's height is dependent on mother's height. Okay, for that we have taken 5 sample, and we'll see that in Excel to find out the answer. Okay, so after completion of this, we'll see the next one, which is multiple regression. So if a particular variable is influenced by many factors, how it will be dealt. Right. Now, if you remember that this is what a simple equation of a line, y is equal to mx plus c. Okay, where x is independent variable. Here x is mother's height. The height of mother is treated as x, as we are feeling that this is impacting the height of son. So we are, in this case, we are feeling that height of son is dependent on mother's height. Okay. So if you just go through that one, we need to find out the slope of this particular equation. Okay, so if you try to fit a particular regression line, we have to find out what is the slope of that equation and what is the intercept. Okay, and if you just use a simple thing, like if you just, I'm just taking this one. If you use simple one minute. So this is what a simple graph. Okay, if you try to fit a trend for that, I hope you are observing, you have to just click a trend line for that. So this is how Excel operates. Once you are okay with Excel, then we'll see how manually that regression line will be fitted. Okay. Now, this is what the fitting of trend line. And if you want to see what is the equation form, you have to just go for more options. And here, if you just you see, and you can see here automatically that linear will be highlighted. Okay,
Mhm.
so and if you just go down, you have to check this display equation on the bar on the chart. Now
Mm.
we have got some equation on the chart and display r square. So I hope you remember what is the meaning of r square, right? What is r square?
Coefficient of discrimination.
Determination.
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 So yeah, so how far that dependent independent variable is defining or determining the dependent variable, as we have felt that. So this as independent variable, so this as independent variable, like mother's height, we have felt that mother's size height as independent variable, and we are trying to see how far this impact will be there on this particular dependent variable. Okay, so this is what we are trying to find out. In that course, we see that determination. So how far these variables are determined by these variables. So that will be given by this r square. Now you can see it is telling that 0.32. That means 32.58%. So that shows that our the sun's height is only 32% determined or impacted by mother's height. So probably there might be other reasons, and tentatively father's height or father might be the other influencing variable. Okay, so this is what our thing, and we'll try to see how that will be done, because we just thought that equation of any straight line, so the equation of any particular thing is straight line is y is equal to mx plus c. For that, we have to check different formulas, and we have to find out what is that variables. Okay, so as we know, y is equal to mx plus c is the main variable. Now we have to find out that slope. How can we get slope? So for getting the slope, we have got a separate formula. Okay, so here it is not there. Fine, no problem. We have to find out average values first. Average values. So since you know average functions, I'm just using that average function. So this is what x variable average, and this is what y variable average. Okay, so now we have to find out standard deviation. I'm just taking the total values, all the 5 values. So I'm just using standard deviation for P. So standard deviation of total population, first variable to last variable. Okay, and the same thing will be extended for Y variable also. So now I've got X, this is X bar, this is Y bar. Okay, so these two are X bars and Y bars. And so this is standard deviation of X and standard deviation of Y. Okay, so now I've got these values. To find out that slope, we should have correlation and standard deviation of both the variables. For that, how can you find out correlation? Because as we have already seen certain classes on correlation and covariance, first you have to find out the deviation of X and that variable. So first you have to find out these three variables to find out that covariance. Okay, x minus xi bar, so x bar minus x or something. So either this one minus mean of this variable. Okay, so we'll get all these variables. So once it is done, we have to find out y minus y bar. So this is the observed value minus the mean value. Okay, so as I have to find out deviation with each and every value, I'll be just finding out, fixing that variable. So now I've got all these things. To find out the multiplication factor or product of both the variables, so I have to just multiply this with this. If anyone feels that I'm going a bit fast, you can just ask me so that I'll try to slow down. Is this pace okay?
Yes, we've done
Yeah,
this part before, so it's okay.
yeah, fine. So you have to just take out that one. To find out covariance, like how these two variables are varying with each other, covariance. For that, you need to find out the total of this one. So this is sum of these values, and you have to find out that average. So that will give you the covariance. So covariance is equal to this divided by how many numbers. And you can use covar function also to find out that one, and correlation also you can find out. But since it is going to be a good practice if you try to find out that values, okay, as you need to find out the correlation. So the correlation will be equal to yeah, please.
Yes, sir. It is covariance upon the product of the standard deviations of x and y.
Thank you. So covariance we already got, and the product of standard deviation of x and standard deviation of y. Okay, so this can be done manually. This can be done with help of Excel also. So correlation is represented with the help of small r. As you have to find out r square. So for finding r square, so just use cap function. So now you see you got 0.328 something. That is what we have got even with our value also. So correlation, Excel has given 0.328 and we also got the same value. So there is no problem in that. And if you see the slope here, in the case of y is equal to mx plus c, we need to find out slope here first. So then we have to find out c value. So slope is found out with the help of m is equal to correlation into standard deviation of y divided by standard deviation of x. If at all, if you have remember your basic mathematics, slope will be simply defined by y2 minus y1 divided by x2 minus x1. I hope you know this one, right? So slope is simply y2 minus y1 divided by x2 minus x1. If at all we have got only 2 points, x1, y1, x2, y2, we would have computed our slope like this only. But if you see, we have got first x1, y1, x2, y2, x3, y3, x4, y4, y5. So there are 5 points and we cannot compute with this formula. For that, what we have thought is like, this is simply telling the deviation. Okay, so we have mentioned it as standard deviation of y divided by, this is also there is some kind of deviation in the x. As it is different points, we have just made it as standard deviation of x. In addition to that, as there are multiple relations, so as there are multiple relations, we have mentioned what is the correlation. So we have to multiply with the correlation. If you multiply correlation with standard deviation of x divided y divided by standard deviation of x, we will get actual slope. So that is how this formula has got derived. Is that clear?
Yes, sir.
Fine. So to find out m, we have to just find out the product of correlation. So here the correlation is here multiplied by standard deviation of y divided by standard deviation of x. So I hope you know BODMAS rule. So based on that, there is no need to find out bracket something like that. Okay. So numerators will get multiplied, which will be divided with that one. So our slope has come it as 1.9. Slope has come as 1.9. Okay. So the next thing, as we have extended y is equal to mx plus c to y bar is equal to mx bar plus c in this case, using this equation, we can find out the value of c. So where c is equal to y bar minus slope into x bar. So this equation has been derived from this simple equation only, the equation which I have mentioned here. So instead of that, I have used, since we have got multiple observations, we are using the average values instead of individual values. So in that case, as c will be equal to y bar, my y bar is here, minus slope, just now I have calculated my slope, multiplied by x bar. X bar also we have calculated. So if you just click that, it will be like that. Now if you try to fit a simple line, so this is what simple line which we are going to fit, that is equal to y cap or y hat. So here I've just mentioned y cap or y hat. So this is what the next equation that we have to do. Okay, so y cap is equal to mx plus c. So in that case, my y cap, I'm just using here, y cap is that value, right? So now I have to just find out the prediction values. Okay, so now I have to use the predicted values. Okay, so which is equal to my slope is 1.9, okay, into x value, that is observed value, first mother height, plus the c value, which is this one. Okay, so as it is a minus value, I am just using a bracket to close that one. So this is the first expected height. By using this trend line, as I got it as like y is equal to 1.9. So here my predicted line is equal to y is equal to 1.9x plus c value is 127, that is minus 127. So this is what my predicted line. Is that clear till this point? So Swati, Varsha, is that clear?
Yes, sir.
So I found out m value, slope value. Using that, I found out c value. So once after finding these two values, I fit a trend line or regression line as 1.9 x minus 127. So where my slope is 1.9 mx plus c, and c value is minus 127. Using that value, I'm trying to check all the initial values. Okay, so all first value is observed to be c, that is my slope is 1.9, so that is multiplied by this value. Okay, so I think d4 is my slope. So I'm just fixing this value because I have to find out every value like that, all the 5 observations. Okay, so I click that one. If I just try to drag these 4 to the next one, I think there is something wrong. So is equal to m and multiplied by x plus c value. So this also should be taken. Okay. So if I just try to drag that to the last, okay, the second prediction has come as 154, but actual value is 147. According to this line, second prediction should be 154. Third prediction should be 152, but actual height is 155. Fourth prediction has come it as 158, but actual value is 158. So there is no deviation here. Fifth prediction has become 156.1, but it should have been 160. So these are what my predicted values. So is there any deviation between actual value and predicted value? Now there is no need with the correlation and the c value. Is there any deviation with the actual value? So these are actual values and these are my predicted values. Is there any deviation between these two?
Yes, sir.
151 has become 150, 147 has become 154 point something, 155 has become 152 point something. So there is some kind of error. Okay, so that error is what my yi minus y hat or y cap. Okay, so that is what my error value. So this is the actual value minus my predicted value. Okay, so like that, in first case my error is 0.6, in second case my error is minus 7.2, very big error. In third case my error is 2.7. In fourth case my error is 0, there is no problem. In fifth case my error is 3.9. So that is what you can see here. Okay, in this line, so this line, dotted line is my predicted line, y cap or y hat, and these are the actual points. Okay, so you can see a small deviation here. In the second point there is a big deviation. In the third point, very huge deviation. Fourth point there is a deviation. Fifth point there is no deviation. That means this is 158 and 158 something. Okay, so this is what the error value. Okay, if I try to find out the square of error, okay, so square of error, so square of this error, so all these errors. Okay, So if I try to find out square of errors, I've got all these things. Now I have to find out some sum of square of errors. So that is what SSC. Whether you have already gone through something called as ANOVA, because in last class, sir was mentioning about ANOVA. Have you, do you have any idea of ANOVA?
Sir, just know it is analysis of variance, not done
Fine.
it.
Yeah. Analysis of variance, definitely we'll see that. In ANOVA, you are just trying to analyze variances of two or more different sets. So here there are different set of numbers. So first set of numbers, second set of numbers. You're trying to see what is the variance in this and this. So that if it is more than two variables, usually ANOVA will be used for more than two things. So three variables, four categories, five categories, five groups. So five groups of variance will be done. So even in that case, you will come across something called as sum of squares of error, sum of squares of regression, sum of squares of total. You have to remember three aspects: SSE, SSR, SST. So this is what error concept. Okay, so there is some sort of error. We have got this value. So, and if you just see, this error is the difference between my point and my regression line. Okay. Now, the second concept which you are going to see is the difference between mean value of these particular points and this particular line. Okay. So that is usually mentioned as this one, y bar minus y cap. Okay. I'm just copying this one. You will be just trying to find out y bar minus y cap. So my y bar is standard, that is average of y. So this, that one. So this is standard minus my y cap is the predicted value. So 150 is predicted value. Okay. So I've got different predictions. So first prediction from the average deviation. Second prediction, average deviation. Third prediction, average deviation. Fourth prediction, average deviation. Fifth prediction, average deviation. Okay. So here y bar is my average value minus y cap. So minus this particular value. So 154.2 minus this value, like that. So if I just try to find out square of this value. Okay. So I'll be just trying to find out square of this value. So sum of this value is called as SSR, sum of squares due to regression. Okay, so this is what, so this is sum of squares of error. Okay, and so this SSR is sum of squares due to regression, because I have got some regression line y cap or y hat, and I'm trying to find out the deviation with that and my mean value. Okay, the next value is sum of squares due to total. So that is what the last one which we have to find out. So that is the difference between, if you see this one, y bar minus yi. So y bar minus yi, I'm just taking this one. Okay, so y bar is this value which should be fixed, minus yi is this particular value. Okay, this much. You have to just find out all this completely for 5 values. Like, so this is just a comparison of this one. So we have just taken that one and we have to find out the square values. So this square. So try to find out square for all these values and try to add that one. So if you try to find sum of these values, so this is sum. So sum of these values. So this is sum of squares due to total. So SST. Now, if you just see, there is a cross verification that we can do. SSR T should be equal to SSR plus SSE. Okay. So what is our SST? It is 110. You can see here it is 110. Okay. If you try to add these two values, that should be equal to this one. Okay. So this value plus this value. So this is 110.8, right? And we have got 110.8 here. Is that clear? Because if you just get like this, then we are sure that we have done the problem correctly. Fine.
Sir, this
Yeah.
column number E.
Column number E. This one.
E is same as to that column number L. Yes.
Yes.
But here sign values
Minus
are
sign.
why
Because
this?
because here I've just used y bar minus y, but in this case I have taken yi minus y bar. So C4, I have taken this minus this. Here I have taken
Opposite
C9
of
minus C4. Yeah.
Huh.
Because as I'm trying to square this value, I did not
It's
take
not
that
a
value.
big thing.
Sorry?
It's not a big thing because my square will change to plus sign.
Yeah. For that reason only I've taken this one. Otherwise, ideally, I should have taken y bar minus this value. So these two are same. Here, if you observe, I have mentioned C4 minus C9. Okay. But here I've just made C9 minus C4. That's why I got a difference of sign. Okay. Fine. So I got SST is equal to SSR plus SSC. Even in your ANUVA, you are trying to find out these three only. But for more number of groups, here you have taken only mother height group, son height group. If you take other things like father height group or brother height group something, you'll get more than two groups. So if you try to do the same problem for that thing, it will be treated as ANUVA. Nothing more than that. Is that clear? Yes or no?
Sir, in ANOVA, then your variables will increase, yes? So
yes.
then, like here, it was only X and Y. Suppose Z is also there, then how it will be done? Z with Y, then Z with X. Is it something like that we have to do?
Usually that should be like that only, because you're trying to see group 1, group 2, group 3, group 4, more than that one. Okay, for that probably you might not be doing all these things, but I'll tell how to do that one. Okay, so next concept is going to be that only. Is that fine? But the concept is this sum of squares due to total, sum of squares due to error, sum of squares due to regression. These three remain same even in ANOVA also. So that is what I mean. Is that fine?
Yes, sir.
Okay, now here for R square, coefficient of determination. So coefficient of determination, there is a formula for that. R square is equal to SSR divided by SST. Okay, sum of squares due to regression divided by sum of squares due to total. So sum of squares due to regression is 36.1 divided by sum of squares due to total is 110.8. Okay, so that is 0.325812. Now you see this is the third check that we can do. So initially Excel has given 0.3258, right? Okay, so the first check is Excel has given us this value R square. With our correlation coefficient, we got R square as this value. This is the actual formula for coefficient of determination, SSR divided by SST. Here also we got 0.3258. So that shows that we have done problem correctly. Fine.
Yes, sir.
So these are the three checks that we can do. Even you can perform the same problem with your manual by hand calculation also you can do. You will be getting the same answer. Okay, so for that you have to do. And most of the people will just stop with only this one. Okay, so they will not go to regression square because you have completed PhDs and you're almost into that one. You should know how the backend work of regression will work. Okay, so this is what, and as these are the observed heights, and this is what the predicted line, the mother height is able to explain only 32% of the variation in the sun side. So that is what the inference that you have to do. Either Excel or manual calculation. Calculation is not at all a big deal. Since we are teachers, you should know what is the implications of these things. And particularly, R square will tell that only 32% of variation in sun's height is determined or explained by mother. So this is called as explained variance. Okay, if you just go in depth to analytics, this is called as explained variance, and the remaining things like SSE divided by SST, which is called as unexplained variance. So the line or the trend line which we have created is not able to explain certain variance, which will be obviously 0.68, right? Because 32% of the variation is explained by mother's height, 68% we could not explain with mother's height. Maybe father's height or some other variable is there. So that other variable has influenced this particular thing. So that is regression. Is that clear? Coefficient of determination.
Yes, sir.
Okay. So I've got some more some more problems. Like if you invest in R&D, so this is the other problem. If you invest in R&D, your profit will be like that. If you just see, for just example, I'm taking this has R square of 0.9041. That means this shows that 90% of the variation in profit is explained by R&D expenditure. Only 10% are other factors, or this equation could not explain. Is that clear? And if you see the correlation between these two variables, it is 0.95. And in the previous case, the correlation is 0.57, only 0.57, not a serious or perfect correlation. But in this case, if you see the correlation is 0.95, that means almost perfect correlation. And whatever the variance is happening in the profit, it is 90% of this variation is explained by R&D expenditure. Only 10% are other variables. Clear, maps?
Yes, sir.
Okay, so now I am believing that you are okay with this particular linear regression, which will be caused by one variable. Suppose here there is some problem which is example for multiple regression. Okay, so multiple regression simply deals with this sort of things, wherein I'm just taking that one. So here, if you see the behavior of variables, okay, this behavior of variable is done, or this y variable is changed because of multiple variables. Okay, so when multiple variables have made something, so then we have to fit a particular line, and probably as we will not be able to do as in earlier case. Now if you see, there are different homes, like there is a data about 30 new homes. Okay, home one price is, assume that $505, and how many square feet it is? It is 2192 square feet, and lot size is something 16.4, and how many bathrooms? It has got 2 bathrooms. Okay, and if you consider second house, the price of that house is 784, very high when compared to price first house price, and probably the square feet is more, 3429, and lot size is also more, baths is also more. Since all are more, obviously we can expect a higher price. Coming to the third house, so third house $649, and comparatively higher in terms of square feet, very less, there is small deviation between lot size and baths. So in that case, I've got this is the house number. You can just take out this one. I've got 3 more variables. So among these variables, which variables are independent, which variables are dependent? What is y? What is x1, x2, x3? Assume that you're trying to find
So X would be price.
X would be price. Okay.
Based on that, means it would depend. Price would depend on. Uh, no, X would be square feet. Square feet would be X. That would determine what would be the price, what would be the lot size, and what would be the bathroom.
Okay.
Dependent variable would be the price. Yeah.
Sorry. Second person's opinion.
So price would be the dependent variable and
Y variable. Nice.
y variable, and the square feet would be the area would be x1, lot size x2, and baths x3.
Fine. Absolutely fine. So this is what one variable, price variable, is dependent on square feet, lot size, bathrooms. So if you see this one, so there is one particular thing, price is 822, very high price, because square feet is also more. It has got 4 bathrooms, it has got 26.9 lot size. So now as a statistician, you may get it out like which is the most impacting variable among these three. So price is dependent definitely on these three things. Either do you feel square feet is more impacting, lot size is more impacting, bathroom numbers are more impacting. For that, we need to do this regression. Fine. So if you see, like India won World Cup or India lost World Cup, something like that. So we'll have multiple variables for that. So, and finally, we have to give a man of the match or man of the series. For that, you have to identify like which is the most crucial, who is the most crucial player, or which is most important among these three. But by seeing this, we cannot simply tell that either square feet is more preferred by people, or lot size is more preferred by the people, or baths are most preferred by the people. Okay, for that, you have to fit it a regression line. Okay, this is an example for multiple regression. Okay, because your price, the dependent variable, is depending on 3 variables, and we are not sure which is the most influential variable or which is most important, something like that. Okay, so for that, you have to just use data, go to data analysis, and so there is something called as regression here. Okay, so just click that regression, and it asks for input y range. What is my y variable? Price.
Price.
Okay, so I've started and I've used control shift a down arrow to select all my prices. Okay, and what is input range? My input range is square feet, lot size, baths, of all these things. Okay, at a stretch, you can select all the 3 at a stretch, right? So I've clicked that one. Next, am I using any labels here? When I have selected, I have taken care that no labels have got selected. If I have taken right from home, square feet, lot size, bars, I should have checked this one. But now I have not selected from that. I have selected only values. So I'm unchecking this one. And confidence level. Remember, confidence level usually will be 90, 95, 99. But majority of the people prefer 95%. Okay, whatever the regression line that you are fitting now, it is 95% correct. Okay, because we cannot give 100% assurance in anything. So that's why I am leaving this 95% as it is. If I just want to make change, I have to click here. Maybe I can make it as 90% or 99%, something, but prefer it should be 95 only. Okay, and coming to the output range, I'm just trying to take my output here only so that I can see that one. Okay, and if at all you want to see any plots, residual plots or something, you can just click that. Otherwise, take only this one. Some of the people will take residuals, like any deviations are there, something like that. So otherwise, you can just fit this only. Okay, I'm just clicking enter. Now I can see many things have happened. Okay, so now our duty is to explain these things. Okay, and I've just mentioned something called as residuals values. Okay, so here if you see, I'm just taking this particular values. So 30 observations I got, right? So I'm just taking here, copy and pasting. Okay, first observation. So 1 minute. So I'll click here so that it will be good for comparison. I hope you can see this, right?
Yes, sir.
Okay, first The actual price was 505. My predicted price was 495. Okay, so this is what the first prediction. If I take sixth value, the actual price was 590. The predicted price was 603. If I consider 16th value, my actual price was a 675 something, and my predicted price was 682. Now you can see these are the 30 observations. I've got 30 observations values. Okay, and residuals means some kind of error. That's what, nothing more than that. Okay, so error is 505.5 minus 495.16. This is what residual. Okay, residual in this multiple regression, residual stands for a simple error. Okay, and coming to the summary output here, the important aspects are the number of observations. How many number of observations? As I have mentioned, I've got 30 values. Okay, I'll be sharing this sheet with you so that you can have a better understanding. So 30 observations are there, and my if you see this r square, it is 0.95. That means these three variables are explaining 95% of variation in the prices. Okay, in the last example, we have got only one variable, like how much percentage it was explaining. But here there are, as this is a multiple regression case, so these three variables are contributing to 95% of the variance in the dependent variable. Clear? Is that fine? Or any doubt? R square, as we are talking about a multiple regression, these three variables are contributing to 95% of the variations in this one. That means only about 5% or 4.9% variation is not explained by these three variables. That three variables that 5% will be maybe the attitude of the person, risk-taking ability, something like that, right?
Yes, sir.
Okay. And if you see ANOVA, so this is what I just wanted to tell. At ANOVA problems, we'll see separately again. Okay. So in regression related thing, this is what my SSR. Okay. So you can see SSR value as 2314 point something. This is what, as I told, residuals in multiple regressions is equal to errors in the linear regression. So this is SSE. My SSE is something, and so this is SST. My SST is, if I just add these two, I will get 24, 3, 3, 1, something like that. Okay. And if you see ANOVA table, since you have completed PhDs, definitely you might have seen ANOVA table. So degree of freedom. How did I get the degree of, so this degree of freedom as 326.9. So this is what I just got, degree of freedoms. It is how many variables I have taken: price, one variable; square feet, two variables; lot size, three variables; baths, four variables, right? So this SSR for degree of freedom, it is going to be 4 minus 1. 4 minus 1. Okay. That is the reason why we got it as 3. So here, residuals. So total how many observations? So here we got residuals as 26. Okay. So how did we get that? Means total number of observations minus how many number of variables? Price is one variable, square feet is second variable, lot size is third variable, bars are fourth variable. So if I just use 30 minus 4, it is going to be 26. Sum of squares of total. Okay, so this is the total number of variables minus 1. This is simply n minus 1. Okay, if we just see for this total, it is going to be n minus 1. Degree of freedom, if you see any textbook, you'll see like this only. Coming to the regression, it is going to be k minus 1, number of variables minus 1. And coming to the residuals, it is going to be n minus k. Okay, so this is how you have to read this particular table. Okay, so interpretation of this table. Okay, And now this mean square, ms. So how will I get mean square? Here there is some sum of squares, right?
Sum of square by number of observation.
Sum of squares divided by degree of freedom. That's what. Okay. So whatever is here, if you divide that with this, you will get mean square. 11, 8 something divided by 26 will give you this one. And f value, f static value, if you divide this by this, you'll get this value. And you can say a significance 3.75 e into 10 power minus 17. Majority of you have completed your PhDs. Definitely you might have come across this. Like, are these three variables are significant or not? It is 3.7 into 10 power minus 17. Significant or not? Because as we are trying to find out 95%, okay, it should be less than 0.05. If it is anything less than 0.05, we feel that it is significant. Okay, it is significant if it is less than that one. Okay, so less than this value. If it is more than this value, 0.05 means we feel that it is not significant, right? Fine. And you can see down we have got certain 4 values: variable x1, variable x2, variable x3, and intercept. Okay, so y is equal to, as we have just started the concept, assuming that y is equal to something. Where is that gone? Some
mx plus c.
Yeah, that is for linear regression. For this multiple regression, we have seen that y is equal to b naught plus
b0 plus b1
x1 plus b2 x2 plus b3 x3. Here we have got only 3 variables, right? Okay, b naught is intercept, b1 is first variable, that is square feet, b2 is second variable, that is lot size, b3 is third variable, that is number of bathrooms. Okay, so if you see, this table will tell about which are important. And if you just see that value, you can feel that the equation of that line, so y is equal to b naught, I have mentioned, right? So whatever the coefficients are there, so these are values related to b naught. So this is b naught, this is b1, this is b2, this is b3. Okay, so these are coefficients. The equation will become y is equal to minus 23.21. It is a constant, plus 0.18 into x1. x1 means number of square feet, plus 6.60 into x3, sorry, x2, which is lot size, minus 0.09 into x3, which is baths. Okay, I've taken plus and minus because the values are here. This is a plus minus value, this is a plus value, this is a plus value, this is a minus value. Okay, among these 4, which are significant, which are not significant? There are 2 checks for that. If you see p values, so as I've mentioned, if it is more than 0.05, we have to tell something. If it is more than 0.05, it is not significant. If it is less than 0.05, it is significant. If you see intercept value, what is this p value for intercept? 0.46. Is it more than 0.05 or less than 0.05?
More than 0.4 is more than 0.05.
So is it significant or not significant?
Not significant.
Not significant.
Exactly, it is not significant. If you see second variable, x1 variable, 1.2 e power minus 12, that is 1.2 into 10 power minus 3. Is it more than or less than?
10 to the power minus 3. Minus 3 means?
Minus 12, 10 to the power of minus 12.
10 to the power minus 12 is too small. It is very less.
Very less. That is, it is very significant. Okay.
Oh,
I hope
okay.
we understand.
10 to the power minus 12. Yes.
Yeah, it is going to be 0.00000 long back. So that is most influencing variable is x1 variable only. Okay, that is square feet. If you see the third variable, that is x2 in this case, 0. Very less. Okay, this is also significance. But when compared to these 2 variables, which is more significant?
x1 is more significant.
Exactly, square feet.
Then after that x3.
Yes. And coming to the x3 variable, it is 0.99. Is it significant or not? First thing.
0.99, it is not with E. So
Yeah.
it is more than 0.05.
So it is
Not
not
significant.
significant.
So only this is significant.
Yes. Intercept is not significant.
Even this
Number
is
of,
also not significant. S2
yes.
X2 is also not there.
X2 is significant because 0.00001.
Triple zero, yes,
Triple zero.
means.
Okay.
Mm-hmm.
I try to just make somewhat bigger. Okay. So now is that fine?
Yes, sir.
Okay, so this is the first check to do that one. And there is something called T stats. Okay, so this is our next topic, probably for tomorrow, T value. So T test, Z test, F test, ANOVA something. So I'll explain this T test in the next class tomorrow. And the second check whether it is correct or not, if you see this particular value, intercept, okay, and there is something called lower upper values. You can see this, right?
Yes, sir.
This is lower is minus 87, upper is 40.70. In these two values, can you find in between any zero is there? Minus 87 to
Yes, it
40.
will be
There is a
zero. No?
zero. So a zero is existing in between lower limit and upper limit. Okay, so lower and upper limit. So I'm just mentioning lower and upper values. Okay. If there is a zero existing in between that one, it is not a significant variable. Okay. If you see the second variable, so lower and upper, because you'll be having a repetition here on the right side. The first lower value is 0.15, upper value is 0.21. Is there any zero in between those two variables?
No, it's
No.
all on positive side.
It's only completely positive side, no zero. If there is no zero, that definitely is a significant variable. So that is the check that you can do. Okay. Third case. So 3.47, 9.7. Is there any zero in between these two values?
No.
Both are positive values. There is no zero. So this variable is also a significant variable. The last one, if you see minus 19 to plus 19, is there any zero in between these values?
Yes.
Definitely zero. So that shows that this is not a significant value, significant variable. Okay. This is how you can just find out that. And here in this, there are certain instances where you'll be getting both negative values. Lower and upper will be negative. Either complete, both are negative or both are positive. That shows that variable is a significant variable. So these two are significant variables and the other variables are not significant. Okay, so this is not significant, this is not significant. This shows that if any customer is purchasing, so first preference is the most 0.0 values. The first preference or first priority is only for square feet. The second preference is given for lot size. So these are the two impacting variable. Even if you do something on baths or number of bathrooms, that might not be differentiating your sales. This is the thing. Is that clear? This is multiple variables. And if you see this regression, like a plot, something which we have done. So this shows that how far is that one. So this shows whether we are dealing with normal or not. Okay. If you see these values, it is continuously growing. It is continuously something. This shows that this follows a normality thing. Okay. And if you see the first variable is something like x1, price and square feet. So this is x2 variable 2, that is square feet something. And this is x3 fit plot something. So this is not that much impacting. Okay. Fine. And why, if I just try to make this bigger, blue things like blue is actual value, orange dotted is a predicted value in all these cases. Okay, so in all these cases, blue and orange differentiate the predicted values. And if you see this one, that is somewhat good prediction only, because and the signal r square value is 0.95. It shows that your trend or your regression line is very perfect. Okay. And standard error, some and adjust r square. So that we'll see in the next class. Till this portion, is that fine?
Yes, sir. Sir, F value is actually the ratio of mean squares. Yes. What
Yes.
more does it speak, sir?
It usually tells about like the variance of first variable to second variable, or the dependent variable to independent variables. Okay. And if it is there is something, if you just see that F table based on degrees of freedom, there should be some threshold limit. If it crosses that limit, that shows that significance or not. So these two are somewhat related. Okay.
Okay.
Once we see, yeah, so this tells about whether that variable is having a serious impact on dependent variable or not. So since we have got a group of variables, so these variables are having definitely a significant impact on these things. Okay. And once you see ANOVA problem perfectly, so then we'll come to know what exactly is F, because F is equal to S1 variance in the first variable divided by variance in the second variable. So that we'll see in the next class, because anyhow ANOVA is next class we'll see t-test, ANOVA, and some other things, right? Probably tomorrow's class. And I'll just start the basics of a t-test, and this is what the procedure for regression. I'll share this with Farah so that she can share that with you. And so tomorrow we are going to see a simple t-test, paired t-test, unpaired t-test, ANOVA. Because if you just know one, it's going to be the remaining things are quite similar to that. So this will complete the parametric test, and the last unit is going to be non-parametric test. So probably we'll complete that by Monday. Okay. So, and most of the people don't know that t-test has been given by this person whose name is Gossett. Okay. Everyone feels t-test is some t something like that. So this is he is the person who has given that concept of t-test to the world, and why he has made it as student t-test and something that history that we'll see tomorrow's class. Is that fine? Fine. Okay, fine. Ma'am, Farah ma'am, I'm done with for today's class.
Thank you, sir. Nicely you covered
Thank
all
you.
the
Thank
issues.
you. Yeah, thank you,
sir.
sir. Yeah. Ma'am, Farah ma'am, can I close session for today?
Yes, sir. Yes, sir. We can close the session. And sir, tomorrow we have class, right?
Yeah, mostly I'll take the class, madam. If at all any problem, I'll confirm by 1 o'clock, but 95% I'll take class. Okay.
Yes, sir. Thank you, sir. Thank you,
Thank you.
sir, for managing everything.
Yeah, no, thank you. Thanks a lot. Thank you for your cooperation. And even the students, like whenever we are changing the schedule, they're coming. So thanks a lot for all the students.
Yeah, thank you, students, also.
It's not students, faculty, and I hope they'll be able to understand my problem.
Yes, sir. Yes, sir. You're right.
Yeah.
Thank you, Varsha. Thank you, Swati, for regularly attending classes.
And asking doubts also.
Yeah.
That makes me to learn more.
Correct.
Right.
Correct, sir.
Thank you,
Oh,
sir. Good
okay.
night.